Okay, this is it. Let's wrap this up. Chapter 4. Let's be done with this. Barrier islands. We have these along our coast. They are sand islands. Big enough storm comes, they move, which is kind of scary because there's a lot of hotels and homes out on them. They protect the inland area from storms. Again, they move. So be careful about buying on a barrier island. In between them, there's a waterway. We call it the inland waterway. It's usually brackish water, a combination of fresh and salt. Again, in between the islands and the coast. This whole area, the beaches and stuff, are often a very important area for nesting and nursery areas such as organisms such as sea turtles and birds. Again, storms will shift these islands. They'll shift the sand and shift the islands, which can be quite interesting if you have hotels on them. Human impacts we do. We build resorts, hotels, homes out on them, which just disrupts their natural function. We also, if the hurricanes come and take the sand away, we often put it back, which is a huge disturbance doing that to the organisms in the area. Disrupts natural vegetation and nesting areas for sea turtles and stuff. Although here in Florida, we're pretty good about now saying that if you're on the boat or the hotels, a lot of them have barriers of bushes and stuff to block light, or it tells you to close your curtains at night or turn off the lights in your hotel room so you don't disorient the sea turtles, which is very good. Coral reefs. Coral reefs are found in warm, shallow water. They are the most diverse marine biome or habitat. Lots and lots of different organisms are there. There's both natural and anthropogenic impacts on them. Anthropogenic meaning human caused. Pollutants are causing problems. Sedimentation coming out of our rivers is causing a problem. Coral bleaching. The algal symbionts in the coral, which are zooxanthellae, are expelled by the coral, and when they expel their algal symbiont, it actually causes them to die. We don't know why they're expelling them, if it's a disease or environmental change like global warming or something, we don't know, but it's happening. We are also harvesting coral and harvesting tropical fish for the pet trade, and we do that by usually spraying cyanide, which of course is a poison, so there's a lot of damage going on. As far as pollutants go, we actually think sunscreen might be killing some of the coral reefs because we put it on and then go right in the water, and a lot of it gets washed off, so that's an issue. Okay, nice pretty coral reef. By the way, there's a light on for that camera because otherwise it wouldn't look like that. But very pretty. Okay, open ocean. The ocean actually has different zones. Intertidal is the zone between high tide and low tide. The littoral zone, that is wrong. Okay, we're going to go back up here and change this. This is the neritic zone. This is really funny. It's funny when you catch all this. The neritic zone is the shallow coastal area. This is where most life in the ocean occurs. In this shallow area, lots and lots of critters, so coral reefs and stuff are in there. Vertical designation, you have the photic zone, which is at the very top. The euphotic is the top part of the photic zone, the part that has enough light for photosynthesis. So you have all your autotrophs and your phytoplankton there in that zone. Under that is the dysphotic. It's kind of twilighty, so there's not enough light for photosynthesis, but there's still a little bit of light. And then below that you get the aphotic zone, which means there's absolutely no light. So organisms down there depend on what we call marine snow. Marine snow is dead and decaying parts of other organisms from up above that are literally sinking or snowing down below, and so that's their food source because there is no phytoplankton. You can, when you have hydrothermal vents, which do occur in some locations, you can get chemosynthesis. This is when bacteria in the area use sulfur primarily as a source of energy to make and start a food web, but it's at the very bottom. The other thing you need to know, or the other zone, is the benthic zone. The benthic zone is the bottom of the ocean. Again, just like with a lake or a pond, it's the bottom, whether you're in 2 inches of water or 30,000 feet of water. Okay, so again, we have the intertidal zone here. This shallow part again is the neritic zone. Then you have the photic and aphotic. This is all oceanic. And then neritic and oceanic together make the pelagic. So shouldn't be familiar with that. In the intertidal zone, again, it's a narrow band between high tide and low tide. Organisms that are in this area have to worry about waves. They get crushed by waves. They have to worry about being out of the water for a chunk of the time. If they happen to get trapped in like a tide pool, like these little critters, the green ones are sea anemones, there's some sea stars, and these are all barnacles and stuff. They have to worry about this water that the sea anemone's in. It's going to increase in temperature and it's going to increase in salinity as evaporation occurs. So it's going to get saltier and it's going to get warmer throughout the day. So if those organisms are not adapted to that, they could die. The barnacles and stuff out here, they close up tight to make sure they don't desiccate. Desiccate is the term for drying out. So, and the sea stars will migrate down into the water if they start to get too dry. And I guess we're done. Yay! Finally done with chapter 4. See you guys later.